Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Raspberry Pi products. So let's dive right into it. Now, why specifically we are talking about Raspberry Pi? Well, it started from like 2015, as in like this format started from 2015. They had like some earlier option as early as 2012 and 13, but like this was like the big breakthrough, and it created a huge community. As in, lot of people poured their boatload of money, R&D, and basically creating community guides, OS, and all that jazz into this. Now that created a feedback loop, meaning there were many other companies seeing the early success of this puppy. There are many companies that are like, I also want to jump into this, but majority of them fail simply because making this is child's play. Making sure you support this puppy, yeah, good luck with that. That's the whole thing. It's like you can literally find there are other boards, like even technically they have much higher performance, but good luck trying to even run YouTube on them. Like some are supported, but you get that point. Like you need a community that is sorting the whole operating system, because hardware is just one thing. Without software, without tight proper integration of hardware and software, it's garbage. Now this puppy has sorted that issue out. Now you launched something, it became successful, it created a huge community. That meant you sold even more units. So their graph, it looks like this at this point in time. But I'm talking around 2021 and 2022, they have crossed around 40 million units. Now that's a lot. I mean, a lot. Now you may have to understand, like that number may not sound very huge if you compare to, let's say, a mobile phone. However, for something like this, basically it's not a product, it's not something that you can give to someone. It's like you have to know what you want to do before you buy this. It's one of those kind of product. It's like a lab tool kind of product. It's not something like if somebody, like parents ask a computer, you give them this. That's not how this works. So considering that, having this kind of volumes, like 40 million, creates a lot of interest. Now company, basically the company behind this, looking into this, realizing that they also created a lot of formats. For example, this is a credit card size format, this is older format of basically Pi 0, and they have this format, modern format of compute module 4, and they also had a RAM module format which they utilized in basically older version of that. Now it has created even larger community in corporate environment, meaning there are people who are making products with this product, as in like, I'm gonna give you this is a product. So that kind of environment. So why would anybody want to use something like a lab grade tool for making products? Well, reality is there are many things nowadays. For example, 99% of the things that we want to do in like internets of things kind of scenario, they all require low level PC. You may be tempted trying to like properly just do that with a microcontroller, but reality is good luck with that, because if you try to do that, you have to open up everything, meaning a microcontroller, a cheap microcontroller that you can buy off the shelf, is not going to have good level integration, security, or things of that nature. So in those sort of scenario, you need a low power PC, because like again, it allows you to deal with much larger compatibilities, meaning you can deal with web servers, you can deal with a much higher level data logging software, things of that nature. You need a low power PC. Again, I'm not talking about like high end octa-core processor, like running a Threadripper or something like that, but at least a bare minimum old PC. So how does other company deal with that? Well, generally they try to make their custom system, meaning they will either go to Intel, or they will go like any other supplier that is willing to work with them, and they will try to sort that puppy out. Now it does work. Again, that's how everybody used to do this, but the consequence of that was very expensive, because this sort of tools were rare, and they're not gonna sell, one unit is not gonna sell 40 or 50 million. However, Raspberry Pi does sell that. So even though it's far more powerful, it's far more cheaper because it's selling a lot, and like company knows for a fact that there are other companies that are buying like 50-60 million orders. At this point in time, due to chip shortage, they are saying that their number is only 40 million. They would sell a boatload as soon as supply starts to ramp up. Like they have that kind of demand. So of course they can provide much higher quality tool for much cheaper price, but any custom build, yeah, good luck with that. It will be very expensive, and because it will be always a custom build, you have to sacrifice many of the custom basically creature comforts, meaning when you are building a PC like a Raspberry Pi or something like this, it's like it's sorted. It's like you got this, like this is a PC, this can do almost everything. If you want to run a basically a database software, it can run that. Again, I'm not talking about like running a giant server farm into this, but it got this. Like almost every high level function, even low level image processing, even low level AI can be run on this. Like this, but whenever you are building custom, due to cost constraint, you will be like, try to do as minimum as possible. And you can notice that in whenever you buy TVs, like smart TV like this is LG CX OLED 55 inch, you will find that like the smart TV, technically they have smarts, but there's like surprisingly garbage. It's like, why a company that is so huge? Because again, when LG was trying to build that, and whenever you want to fabricate silicon, you have to order multiple millions of it, and that's the problem. So inherently, whenever a company tries to do custom chips or custom like that, it's always difficult. And even if they are buying it from, let's say, On Semiconductor or things of that nature, other Broadcoms or things of that nature, they still have to redesign the board, write the OS, do everything from scratch. It costs boatload of money, and it does always give inferior product. However, if you use Raspberry Pi directly, you have sorted your core, meaning you don't have to worry about the core. You got the core. It's like, okay, if I give it this much voltage, this much milliamps, and this kind of communication bus, it's done, it's sorted, it's gonna boot up, it's gonna take care of the things, and I can just code on top of it. Because coding is never done like, microprocessor, you code on it, there is a bootloader there, like, then you code on top of it. And if you want to remove that and, like, make it even more efficient, again, you have to figure out a solution for that. It's like, how the heck you gonna burn firmware into that? Again, this can be done, but does add cost. Raspberry Pi, forget, don't think too much about it. So that's the whole point. And the operating system on Raspberry Pi is completely open source. Hardware is not, but the operating system is, meaning you can go really deep down, and you can be like, this Raspberry Pi Foundation is like, trying to extract some money out of me, try to do data mine. You can go completely deep into it and be like, I don't think this telemetry data is important to send out, let me delete it, let me block that port. You can do all that things. That gives you really powerful starting operating system. Then the hardware itself is powerful simply because the company can afford to order millions of pieces, and you only have to deal with the functionality that you want to do. Meaning, for example, let's say you want to make a smart TV module, you only have to deal with, okay, how I'm going to interact with that, and basically the software coding of that. If you want to make a NAS unit of that, how the heck are you going to have a SATA bus that is like, multiplied by 4 times or 6 times, whatever have you. Or if you want to do cluster computing, how the heck your board is going to provide power to this many systems. That's all you have to deal with, rather than, okay, computer, then build everything else. It's like, computer, I got this, and then you build on top of it. It's much easier, comparatively speaking. Now, this is a very recent announcement, Home Assistant Yellow. Yes, amazing name, I don't know why, but the reality behind this puppy is that it's a true open source hardware. Now, you have to understand, Internet of Things devices are 100% unsecure. Now, why is that? Well, it's about cost. For example, if you buy a computer, it can have layers and layers of security, from hardware level to firmware level to BIOS level to goddamn operating system layer, and then it has some chance of going into internet without going poof. But when you're talking about like Internet of Things bulb, like people are like, hey, I have this bulb that is Wi-Fi connected. How much money do you think they can put into the microcontroller that is on that board? Like, do you genuinely think that they can afford to put like, 512-bit encryption bus on that? No. Again, physics allows that. It's just like, would you pay $10,000 for a goddamn, bulb? No, you can't. And that's the paradox of it. Due to the cost factor, inherently all IoT devices are garbage on that. However, if you put a lot of IoT devices, even smarter options, which is rather than having like a lot of small entry points into your network, you have a one network choke point, meaning ZV network. Basically, each thing is independent, like nobody can access it from the outside. You will have that one network. It's like very simple, non-commercial kind of scenario. Non-commercial as in like not every Tom, Dick and Harry can buy equipment to talk to it. It's different. It's basically like trying to hide your system and then accessing that whole puppy through a proper computer. Then you have a proper kernel level security. Then you have proper encryption system. All that layers of firewall, then you can put in one central point, rather than, oh, my light bulb also has this firewall, my air condition has this patch issued. None of that. Only one central point. It's much easier to reinforce. It's much easier to make it solid, where it's like, no, this puppy can handle this, rather than randomly you waking up, it's like, wait a minute, my fridge is consuming a bit too much power, or because somebody is mining on it. Yes, it has happened. So you have to understand, people are waking up and they're like, I genuinely do not like the idea of like Amazon listening to me 24/7/365 until the day I die. People don't like that option. So people want something that is open source, meaning they can actually go down and have a community of people going down into it. Is like, what is this telemetry data? How this is working? I want to look into it. So in those sort of scenario, this sort of puppy was born. Now, this gives you complete control over your data and security, meaning if you want this puppy to be even more secure, you can go down, like you can really nail down like how the heck port forwarding is working. You can create some so robust architecture for your firmware level, or even a firewall level, where it's like if some hacker tries to get into it, the port behavior will change and it's like, I think I should cut it down. Again, you will lose your functionality, but at least you will not be compromised. So people are doing that. And not to mention, you can just disconnect it from net. If all you want to do is automation, meaning is like, hey, if I'm in a bathroom, turn on the water heater. If I leave the bathroom and like, let's say there is nobody there for like 5 to 10 minutes and you're still detecting water level dropping, trigger alarm because you may have water leaking or faucet is open. Again, these are simple automation. Again, you can do hundreds of these things in a household, but you need a competent computer to run that. Ta-da! And you generally do not want to link them with internet. Ta-da! So that's the whole point of it. It can automate everything without even touching the net. And that also creates another benefit. It bypasses any paid subscription. And Linus Tech Tips genuinely hates the fact that if he is buying the hardware and still has like, okay, I have to pay for this hardware. I bought the goddamn hardware and still have to pay just so I can use the damn thing. Again, many people have fallen to that, and many startups have like tried to do that and they have been bankrupt, meaning that user data, poof, where is that user data? Good luck with that. So that sort of creates a very uneasy feeling around people, whereas like, dude, Facebook is just trolling the data, Amazon is just trolling the data, so how about I don't give them the data? So that's the whole point of it. There is no subscription, there is no hidden fees, and even if let's say the company goes bust, this whole equipment can be upgraded, used, refined, because it's open source. And not to mention, let's say tomorrow, or not even tomorrow, let's say you bought a 2 GB RAM variant, and let's say tomorrow chip shortages sorts out, you have a normal pricing of compute module, you can put a 8 GB model and can do even more powerful automation. So all that things can be done. And what did company had to do? Basically, the company that made this, they had to make the PCB, which you gonna do anyway, one way or the another. Heck, nowadays making this sort of PCB is super easy. Like literally, there are YouTubers who can show you how to make this sort of thing and order it. And if you select your part properly, you can literally give it to a PCB manufacturer. It's like, here's the finished product. They also have pick and place robot. So if you part order properly, the end, like you just send a file, you have a complete hardware. You don't even have to do anything other than that, other than like, you know, talk to some plastic manufacturers, like how the heck you're gonna have the case. Super easy. So that's the whole thing. PCB, of course you're gonna code, like that's the whole point. And you want to spend time coding. That what separates like, you know, good product from garbage product. If you have a properly written code where like somebody sat down, properly write it, properly figured out the user integration, it's gonna be amazing. Like, why do you think Apple is Apple? Because somebody very early on sat down, is like, let me make sure this puppy works. Like and why the heck Linux sucks? Simply because Linux is like, you should know before you use it. It's like, that's not how it works, and that's why Linux never becomes successful. That's the whole thing. So you can code, you can create an ecosystem around it where it's like, no, it's a really good system. And then you have to add power supply. Again, they have two options where you have 12 volt or you can have power over Ethernet. And they have amazing Easter egg, so to say. If you buy a non-pro edition, this transformer block won't be there, and it's gonna return here, sorry, it's a pro feature. And they're gonna, like, they have this line PoE injector here, M.2. like, it's a very nice touch. Again, this sort of touch makes you stand out. Like, does that really convey a buyer or seller? Not really, but it does give you brownie points, which if you have enough brownie points does help your basically stock value go up. So it is valuable. Smart home radio, meaning there are generally two protocols and you have to choose one or the other. You can have that radio protocol there, have some real-time clocks, you do want that, have storage option, done. That's the whole point. Like, again, if this sort of thing has been done without this, yes, absolutely, that's the whole point of Amazon and all other Google system, but they would have costed a lot. And you can notice that it does not have as much power as this puppy, simply because from their point of view, but the company that is building this is like Control-C, Control-V, Raspberry Pi, and then build everything around it. From point of Amazon, they had to pour boatload of money just to get the goddamn product off the ground, basically just to have the core that where it can interact with internet. And then you find oh, there was a vulnerability in this and that and that, and it's like, you know, you have a ring system where hackers are just opening the door directly. It's like Control-C, Control-V, open the door, and insurance companies denying your insurance simply because, well, there was no break-in, we will not pay you insurance. So be mindful. Surprisingly amazing tool and surprisingly timely arrival. Now that's from, like, you know, home use. Let's talk about some medium to small scale business environment. Pi-KVM, meaning KVMs are generally a tool that allows you to control either multiple computer or one computer through remote access, basically. Now this is a pro level tool. Basically, it is something that if you need this, you need this. There is no compromise around this. You have to have that. And remote access and management is very difficult. It's so high end, meaning server motherboards generally have a dedicated hardware chip just for this. Now, consequence of that is like, they are not, even though there are many server equipments, not all of them have that. Like, it is that expensive. Not every server has this. And again, many servers may have like all the features you want, but may not have the highest grade integration of that KVM function. However, if you use Raspberry Pi KVM, meaning all the company had to develop is this daughter board and this system that is going to go inside your server or inside your computer if you are using old computer, which many radio stations, I have provided an example down below, many other places use that. You can just have a basically buy this puppy, add a Raspberry Pi, done. Now it has a lot of options in commercial hour, meaning HP also makes something like this, but this is expensive, as in like this is very old, I think 10 years old, and it's like 33,000 rupees. I can get this puppy for 10,000. So that's the whole point. There are options that are from professional companies, but they are ludicrously expensive because they had to develop everything from scratch. Here is like we have the core, how about we add this functionality to it? Like, think of it this way, like imagine you are yourself as a programmer, it's like, I have a computer, what can I code to it? The answer would be almost anything. And that's what this Raspberry Pi product does. It's like, if we have a whole computer for a KVM, we can do amazing things. So that's the whole thing. And deal with this puppy is that it can do things that are so high level, meaning you can connect this to a computer, and let's say for some reason you found out that it's a Windows computer and it has bricked itself during a basically update. Now you try to reboot and all that jazz, it did not work. But here's the deal, because you can connect this Raspberry Pi as a full computer, you could have a spare pen drive connected to this puppy all the time. What you can do is basically install a different iOS image directly. Let that sink in. Like, from a KVM, you are installing an operating system on a different hardware, and this will work with any hardware, old, new, bonkersly complicated, or super simple. It will work in all of them. That's the amazing aspect of it. That's the whole thing. Like, reformatting a completely different computer with a fresh image of iOS, that's like a whole different level. That's why I specified. Tell a programmer what you can do on a computer, the answer would be almost anything. And the limitations are like, where would you get that spare computer? Raspberry Pi is to the rescue. That's why this is amazing tool. Like, for the people who need this, it's like, shut up and take my money. Now, so far I have talked about how I have talked about, like, low-level business interface. I'm talking about commercial market, meaning NEC Display Solutions, meaning this puppy, Sharp and NEC, they make this display. You would have noticed them in McDonald's drive-through, shopping malls and things of that nature. But these are commercial puppies. Even though the technology may sound the same as maybe same LCD technology, they are built differently, meaning they have armor around them, much higher brightness, the panels are strong. Everything is done in such a way that it can work 24/7, even in outdoor environment, and can handle some abuse. And the softwares that support this puppy behind it is much higher grade, meaning, for example, let's say you are running this puppy on basically, let's say, fast track, and you had a sale, you plonk that PDF file that is like, display this animation for today's sale, and it detects that, hey, that PDF is corrupted or the file did not transfer. It's not gonna like, okay, it's gonna show an error message. It's gonna be like, I detected it, I'm gonna send a message to my client or whoever is like, hey, there is an issue here, and it's gonna revert back to old animation. Or the animation could be even pre-planned, where it's like, for Monday, Tuesday, Wednesday, Thursday, Friday, like this sort of animation. And if you're detecting like how VLC logo changes to Christmas logo when it starts to achieve approach 25th December, you can have something similar to that. So it does require a different level of smartness. Like, it has to be smart. Now, those sort of things people have tried, like, having integrated processor. It can be done, but expensive as hell. Or you can just put a Raspberry Pi into it and done. Forget about it. Like, just make a daughter board, and that daughter board had, like, this is the older version of that RAM stick module. So super easy, tunk, done, go home, don't have to worry too much about it. And this is the upgraded version. This is in the M series, where they have the compute module. Compute module is the heatsink, and done. So that's the whole thing. And now what can you do on this? Anything you can do on a computer, which is a lot. So that's the reality of it. Every Tom, Dick and Harry is now realizing that Raspberry Pi is a computer. If anything requires you to do a computer, for example, let's say you want to build a microwave, and like, I mean, an actual smart microwave which can actually do things. For example, not have an annoying alarm, or have multiple humidity sensor where it can run all of them and average out the data. So it's like, no, I'm detecting this much moisture, this is the how much cooking cycle I have to do. It can log the data in a server where it's like, you know, running all the recipes and all that. Like it can have true smart functions, and you do not have to build a computer. You can be just like plonk, Raspberry Pi, done, go home. And you don't have to worry about like security and all that jazz, simply because again, it's a Raspberry Pi. It's a full-fledged computer with more than enough people looking into the security aspect. And even if there is a vulnerability found, more than enough people are like patching it up instantaneously. So this was just few examples that I wanted to bring out in front of you. So do not look at Raspberry Pi as just like it's just a tool, like, you know, that helps you learn coding or things of that nature. That's how it started, but right now it's amazing. Right now you can do things, meaning you can even run a company on this. So a lot of people are pouring a serious amount of money, and if you had some idea, maybe you are not crazy to think about like, hey, want to use Raspberry Pi as a product. It can be done. People have done it, and these are just 3 examples. There are many more. So this was just a video just to open your horizons a bit. So this was my presentation on Raspberry Pi products. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice or thrice. I would urge you to leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.